Hello everybody. So here we go. We're going to talk about what are called vectors. You guys may have heard vectors in physics class, but what I'm going to do is I'm going to go through the assumption that you have not seen them before ever, and I'm going to talk about them from the very beginning. So this first lecture may be a little on the boring side if you already know what a vector is. If not, it should not be boring or as boring. We'll talk to see how this goes. All right. See what we got going on. So the first question we have to ask ourselves is, hey self, what is a vector? Hey, I'm glad you asked. A vector, if you guys ever saw The Incredibles, is, the big giant, thing is, he called himself Vector because he has not only magnitude but direction. Okay, so when you look at a vector, it looks like a ray from, from geometry, and the difference, though, is that this ray does not go on forever and ever. It has a distinct magnitude. Magnitude is kind of like the measurement. All right. And direction, oh, that's an easy one. It actually has a direction of which way it's going. I'm going this way. And the other two parts of a vector are its tail. Usually there's a dot here for the tail and a dot for the head up on the top. And it just tells you, the tail tells you where I started from, and the head point, it tells you where you ended up if you're traveling. Otherwise they'll tell you, how big the vector is, okay, using the magnitude and direction to find the length of where these two dots should be. We're not going to worry about coordinates yet. We're going to worry about those the week after we get back from spring break. And so let's take a look at how we deal with vectors and dealing with magnitude. Okay. So what does it mean to have equal magnitude? Again, magnitude is a measurement. So I'm going to come here and take a look. I have the tail to the head here. So here I have tail, head. My magnitude is 1, 2, 3, 4 units. And I want to create several vectors. Okay, the way we call a vector is we're going to call this one A. Call them A. And the way that I call it or reference it is A with a little arrow on it. You can have an arrow like this, or there's arrows that are like that. Each way we'll call it a vector. So here I have vector A. I want to create several more vectors that have the same magnitude but not necessarily the same direction. So I can start here and count out 1, 2, 3, 4. And there's my vector. I'll call it B. Or I can have a vector that goes this way. Starts here and goes 1, 2, 3, 4. Ends this way, and I could call it C. Or I can, of course, come here and I can go down. 1, 2, 3, 4. There's my endpoint there. We'll call it vector D. Every single one of these vectors has the same magnitude, same measurement, but they are not equal. Okay? Same magnitude, equal magnitude, but the vectors are not equal. Say what? They're not equal. Okay, well, I'm going to leave it there. So let's go ahead and see, what does it mean to draw something or have magnitudes that have the same direction? Or, excuse me, vectors that have the same direction. Well, vectors that have the same direction. Oh, look, with the same direction. Again, here's my vector A. Same direction, starting point, end point. Well, that means, hey, I can draw this one right here. I can draw a itty-bitty one. Call that vector B. It's the same direction, right? Cross, 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 cross. I could go over here. A really big one. And that's vector C. Maybe you can create some more. Give yourself some time, pause, see if you can create some time. Now that you've created some of your own, what am I going to do? What can I say about this? Again, obviously you can see that they're not equal. But they're all going in the same direction. Some just not getting pulled as far. Like this one's getting pulled further. This one's not, and this one's getting pulled as far. Same direction, but they're not equal. So the question that's burning inside of you right now is, well, gosh darn it, what does it mean for a vector to be equal to each other? I'm glad you asked. To be an equal vector. So again, if I have vector A right here, draw it out. I want to draw an equal vector. That means I need to draw a vector that has the same magnitude and the same direction. So if I can draw that one better. There we go. There's A, here's B. Because vector A and vector B have the same magnitude and the same direction, I can say that vector A is now equal to, not vector A again, but of course vector B. You can draw some other ones too that are the same. They don't have to be right on the same knot. They can be way up here and C. And that C is also equal. Same magnitude, same direction. That's all that it requires to be an equal vector. All right. Now that I've taken you that and you have an idea of what a vector is, how can I add up, or when I have two vectors, how can I add them up? Well, the way that I add up vectors is, if I want to do vector A plus vector B, that's what's being shown here. Vector A plus vector B. I start here. This is my starting point. I slide down, and then I take vector B and I slide it over here to where it lines up from head to tail. Here. And I go starting point, and the head of B is my finishing point. This blue vector right here is A plus B. What you should also notice is it doesn't really matter when I add two vectors if I do A plus B first or if I do B plus A. The vector ends up being the same magnitude, same direction, so they are equal. So it doesn't matter, you can add things, which makes sense, right? Because I could add 2 plus 3 or 3 plus 2, it doesn't matter. Same thing with vectors. Well, that's kind of handy. So again, the way I do that, is whichever one is first, the A is first in this one, that's my starting point, and I'll end up, B is my finishing point, and I draw from starting to finishing. This is A plus B. With this one, B started first, so here I start with B, then I put A, and there's B plus A. So let's see a real life example. So an example of adding vectors. So I want you to, we want to create vector C such that it is going to be equal to vector A plus vector B. Well, which one's A, which one's B? Well, I'm going to make this up. Here's A, here's B. So the way I start is I take A, here's A. I'm going to make a copy of A right here. Start a little lower maybe. And I'm going to go 1, 2, 3, 4. I can 1, 2, 3, 4. Here's A. And then now I need to make B. I notice it starts here 1, 2, 3, 4, 5, 6. So I count over, and it goes 2 up. So 6 over 2 up makes B. So 1, 2, 3, 4, 5, 6, 2. There's B. And now when I go ahead and make vector C, here's my starting point. Here's the finishing point. And I draw a straight line. This vector right here is going to be A plus B. Vector A plus vector B, which is equal to my new vector C. I guess technically I got to have all that. Okay. Cool? It shouldn't be that difficult. So we've talked about, what makes a vector the same, how to add two vectors. Well, what about a negative vector? How does a negative vector work? So in a negative vector, my difference is the head and tail switch positions. So you notice here's my tail. Here's the head. Negative A, all that happened was the head and tail switch positions. It has the same magnitude, same length, which is my magnitude, but opposite direction. 180-degree difference in direction. What was going up is now going down. The lines are still parallel. It's just a 180-degree difference. Okay? You might want to write that down. 180-degree change from A to negative A. And with that, we're able to get subtraction. Say what? Because all subtraction is adding with negative numbers. Oh, wait. We first want to do some examples here with the negative vector. So here's A. Here's A. I want to create negative A. Okay, so again, I just notice how many? 2, 3, 4. The only difference is this is my head. This represents negative A. Okay. Let's sink in for a little bit. Let's take a look at now the subtraction part. So in subtracting, if you're given vector A and vector B and you're asked to find out what is A minus B, well, in order to do this, I first need to find out what negative B is. So I come over off to the side here. I make negative B by making a vector with the same magnitude, but just in the same direction that's parallel, but I'm going to make it in the opposite direction, right? I'm going to put the head on the other side, put the tail there. So there is my opposite of B, negative B. And when I do that, notice that's the same. A minus B is the same thing as saying A plus a negative B. So I again start off with A, grab my negative B, slide it over, put it up, and here's my new vector from the starting point to the finishing point. That gets me A minus B. And this vector represents A minus B. All right, so let's see how this looks in a real-life example. Again, we're going to call this right here. We're going to call this A. We're going to call this one B. And again, I want to create vector C such that this is equal to A minus B. So again, in order to pull this off, I have to create a negative B. Well, negative B, again, this is going 6 over and 2 up, so I'm going to do that. 1, 2, 3, 4, 5, 6, and 2 up. And instead of going up, it's now going to go down. And this represents negative B vector. So to create the A minus B, it's like saying A plus a negative B. So I start off with A. And there's A. And then I put in the negative B part. There's the negative B part. Again, 1, 2, 3, 4, 5, 6, 1, 2. That's negative B. And so my new vector right here, there's my vector C, such that it is A minus B. That little vector is A minus B. Pretty cool. Okay. And these are all I'm going to ask you to do in the worksheet you guys are getting tomorrow. So you need to be able to pull this off. That's it. All right. We're done. I hope you enjoyed it. I hope you're successful. You know, feel free to holler at me and ask me questions later. Bye.